Checking the electrolytic capacitors inside a regulated power supply for two-way radio use by Paul, Mike 0 Whiskey November Uniform, or 26 Charlie Tango 730 if you catch me on 11 metres and PMR 446. Stop. This video discusses dealing with equipment that is connected to the mains when in normal use. The capacitors, particularly the electrolytic ones that are subject of this video, can store charge for long periods even with the power off and the plug removed from the mains. If you need to work on equipment like this, ensure the power is off and the capacitors are discharged safely before continuing. When replacing electrolytic capacitors, always observe the polarity, though if you don't feel comfortable working on anything like this, leave it to someone who does.
Hi guys, welcome back to the channel. It's Paul, Mike 0 Whiskey November Uniform, or 26 Charlie Tango 730 if you catch me on 11 metres and PMR 446. Now, we all at home need to obviously power our radios using a source of 12 volts. Now, obviously you can't put a car battery in the shack because that's really not safe. But with a main supply, what we can do is we can use something like this. This is my power supply that I use. I'm opening it up today because I want to check the capacitors inside, make sure it's all still as it should be. This is something that, if you know what you're looking for, then that way you can decide whether to have the capacitors changed. Now, if you're competent enough to do it yourself, then that's fine, bearing in mind that capacitors can store charge for a long time even after the power's been removed. So this has got a decent heatsink on the back by the looks of it. It's rated at 7 amps at 50% duty cycle with a 9 amp surge. It's got a 1.5 amp fast blow glass fuse in the back, and there's a 1 amp fuse inside it as well. And there is also the 3 amp fuse in the mains plug. Has to be 3 amps. I've took the plug off this, so if I need to test it, now I've got two options. Put the plug back on, or I've got a mains testing point on my bench, which I'd also have to plug in anyway, because I keep that unplugged at all times for safety. Now, there are screws on it, lots of screws, so I don't bore you taking screws out of the thing. I'll stop the camera and restart once I've taken all the screws out. Rightio, it's the next day, because the camera battery ran out unfortunately, but I've taken the lid off this so we can have a look at what's inside. So, we've got a very large sizable transformer with properly isolated primary and secondary windings, which is a good thing. Unlike switch mode transformers, which tend to be primary, bit of tape, secondary, bit of tape, that sort of thing. I've seen the inside of one of those. It's not a pleasant sight. So we've got a small board on the top here, which looks like that's to do with the 13.8 volt regulation. There's electrolytic capacitors on it, and those are the components of interest for this video. Let's bring it in so you can see. There we go. So I'm not sure what you can and can't see because of the way the camera's working. There's another larger board underneath with electrolytic capacitors on it. These are quite large ones as well. 4,700 microfarad at 28 volts. They're polarised components, so they can only go in one way round, so you've got to make a note of which way round they actually go. Because otherwise they will go bang. That's not a pleasant sight. I've made electrolytic capacitor do that before, but that was kind of my own fault for putting voltage through it. There's adjustments on that top board as well for the 13.8 volts, and I'm guessing that's the maximum. Yeah, the one that's for the trimmer for the max settings looks like it's a 50k. The other one, I can't really tell much about it. I think it's the same rating. Yeah, it's 5020s. That's 5k. Don't know. A little fuse inside this piece of heat shrink here. So if that blows, then I think that's pretty much game over without cutting all that heat shrink off and somehow soldering a new fuse in there. And that's on the secondary side of the transformer. That's also on the secondary side. I think this is the main current carrying. This is just the control for regulating the supply. There's two transistor type components mounted to the black heatsink on the back. I don't know if you can see them. One's really large and one's not too bad. We've got a full wave bridge rectifier on the bottom, which has got a capacitor, ceramic capacitor straight across it. It's can't really tell much about that rectifier, but it is very sizable. I'd never found the rectifier in this till I opened it up yesterday, when I was doing the filming for the first time. We're on take 3, by the way. So the fuse holder in the back. I've traced the wiring out already. Got the live, goes into the fuse holder first and then back out the fuse holder to the switch and then to the transformer. Perfectly fine. So it's perfectly safe in that regard. So if that fuse blows, then that's fine. It's also not one of those fuse holders where the fuse stays inside the fuse holder when you take the lid off. It's captive to the lid, so when you take the lid off, the fuse is attached to the lid, therefore no risk of shock. If you do get an really old power supply with a fuse holder like that, change it so you don't get a shock, as long as you know what you're doing. So electrolytic capacitors in these, especially these big ones down here, I'm guessing, because they must be for that, provide smoothing for the DC. If they start to fail, if you're on a radio and you're transmitting, there probably will be a somewhat noticeable hum, and that's not ideal. And over time that hum could potentially get worse as the capacitors start to fail. So if that starts to happen, it's only a few pounds to change them. So if you get the capacitors from a decent supplier like CPC Farnell, RS Components, those sorts of places, then you should be getting decent components. I wouldn't advise getting them off eBay cheaply from China because they might not be within the specification, and yeah, so if you get them from like CPC, Farnell, RS Components, then you should be good. So those are the main components. There's two rather large 5-watt resistors on the back of the thing on the same board as the two transistor components, but I'm not sure what those transistor components are. I believe they could be something to do with the regulation circuit, but I've not actually worked that out yet. So what it looks like it does, looks like it's, let me see how it's wired. Because it's got one of the orange wires going, that's the heavy orange wire going into there, so that's going partly through the that's to do with regulation by the looks of it. It's all to do with regulation. Yeah, so there's no electrolytics on there, they're just on the regulator board up here, which has got an ST chip on it, which I think, did I say that was LM324? So there's an LM324, and there's only 3 electrolytics on there. There's space for other capacitors on there as well, but it looks like it's a board for all eventualities, and there's 2 on the board underneath. Again, it looks like a board for all eventualities. So the reason why you replace electrolytic capacitors is the fact that they do degrade with age. So if you buy the second-hand used power supply off eBay, like a really old one, you might be able to resurrect it if the capacitors have gone pop. If the regulation circuit's failed, you'll get, I think, about 28 volts off the output of these. So you may need to check the regulation circuitry as well, depending on what the regulation circuitry is, if it's easy to fix or not. But the electrolytic capacitors are the first thing that you should really be changing in anything electronic that's a bit elderly, really. This isn't that old because it was from Maplin, and it served me well so far, and I hope it will keep serving me well for many years to come. even when it does come the time that the capacitors need changing. And when that time comes, I will pop a video on my electronics channel, which hasn't got a lot of content on it really at the moment, because I've been focusing more on this one to try and get the numbers up, on how you change capacitors. Because that's more for the electronics channel than it is for this, but this is more for this channel because this is a radio power. This is the sort of power supply you'd use with CB and amateur radio gear, and if those capacitors aren't 100% spot on, then it could introduce hum into your transmission and possibly receive as well. So, although I've not had any hum issues, so it's good to know. So, all it leaves me to do is pop the cover back on, because I don't need to do any work on this. And the first thing I'm going to do is make a note of where those capacitors are. So that's a good idea. I've got a different pen today. It's a stylus pen with it's actually got a laser pointer in it. I could have used that for pointing out where things were. So what I'm going to do is I'm going to take a notepad. I'm going to make a note of those capacitors so I know where they are and what values they are. So the first ones are the two big ones on the bottom, and they are both rated 4,700 microfarad at 28 volts. So I'm going to write that down in my notepad. And temperature is also important on these. Well, there's a 105. 105 degrees Celsius times 2. And on the little board on the top, which is another 3, we've got one at 470 microfarad 10 volts. And the temperature, can't find a temperature on that one. Is there a temperature on that one? Yeah, 105 degrees. So it's kind of important. There's only one of those. Times 1. And then we've got these two here, which are 1 microfarad at 50 volts. 50 volts with a temperature of, it's important to look at this sort of thing now, I can't see temperature on those two. They're also 105 degrees Celsius. It's excellent, they're using 105 degrees Celsius capacitors throughout. I think is the one behind it the same rating? Yeah, so 2 of those. So there's 2 of those. Okay, and the last one, there was another one on the output, which I was struggling to see the value of. 220 microfarad, 25 volts. So 220 microfarad, 25 volts, which is more than sufficient for the outputs. It's 13.8 volt output, and now the temperature, I can actually see it, is 105 degrees Celsius. And that's times 1 of those. So there's about 6 capacitors in there that would need changing when the time comes. 2 really large ones at 4,700 microfarad, 28 volts, 105 degrees Celsius. One at 470 microfarad, 10 volts, again 105 degrees Celsius. One at 1 microfarad at 50 volts, again at 105 degrees Celsius. And a 220 microfarad at 25 volts, again 105 degrees Celsius. So you've got to change them with exact or better than what's here. The values, they should be exactly the same. The voltage can be a bit higher if necessary. higher than the quoted, so that all of the 28 volt ones and the 25 volt one could be actually a 50 volt. It'd still be fine, theoretically. Never tried that. So I'll just change them like for like when the time comes. So I've got a list of those. So I'll show you my list. Bring it in. Ooh, my scruffy handwriting. There we go. So I'll pop it there across the temperature checker and the quick test. So next thing I'm going to do is I'm going to pop the lid back on that. So I won't bore you with that. That's the power supply back into place where it goes, more or less, but nothing's been connected back up yet. It's on because I've just been giving it a bit of a probe with both the multimeter, which is showing 13.8 volts DC, as it should be doing, and I also put the oscilloscope on the outputs just to see what the level of ripple was. It didn't look too bad. I didn't keep the scope on long because I find that scope a bit uncomfortable to look at. It's just there. It's an old Philips one with a CRT in it, and the CRT is a bit flickery. And yeah, so I don't particularly like using that scope if I can avoid it. But it's a good little scope, I like it. It's good for being a bit of a show-off piece actually, that one. So I'm going to try and get a LCD scope at some point, although they don't respond as quick, I don't think. I also, if we go to the chair here, and I've also put that across the scope as well. This is an unregulated supply, and yeah, and I also put my multimeter across it. For no load it's 17 volts on the 12 volt setting, which means it's not any good for radios, so that would certainly not be ideal for radios. I'm going to put some load on that just to see what happens, but that will be off camera and that won't be part of this video. So my power supply is working fine, and now I can start connecting all the radios back up to it. So now I don't need to change the capacitors or anything. So this is Paul, Mike 0 Whiskey November uniform, or 26 Charlie Tango 730 if you catch me on 11 metres and PMR 446. So if you buy an old CB power supply, open it up before you do anything with it, check the capacitors and just change them anyway as a matter of course, and that way you should have a decent power supply. But once you've changed the capacitors, make sure the voltage out of it is set at 13.8 volts. And that's where it should be. You can just use a multimeter across the output to do that. So that's not too much of a problem. Capacitors are, like I say, are available from plenty of suppliers. So yeah, because what you don't want to be doing with an old power supply that's God knows how many years old, like 20, 30 years old, maybe more, is you don't want to be plugging radio gear into it and plugging it straight into the wall just in case the capacitors have gone bad. But the electrolytic ones, the ceramic ones, should be fine. So you shouldn't need to replace any of them. It's just usually the electrolytic ones. So best thing to do is replace them, because otherwise if they do go bang, it could cause issues with the supply to the radio. You could either take your radio out, or if the capacitors are on the way out, it could introduce a lot of nasty hum on the transmission, which is not ideal either. So 7.3s for now, guys, and don't forget, stay safe and look out for each other and watch out for the virus. And if you are going to open up a power supply, just be careful. Pro tip is try and work with one hand in your pocket. So if you do get too close to the charged capacitors, it shouldn't find a path to, well, across your heart, because that's going to be the worst bit. Because some of those capacitors can store a hell of a lot of charge even when the thing's been unplugged for a while. So, and if you must short old capacitors out, just put an insulated screwdriver across them. That should short them out. Don't try putting your fingers across them, because it will give you a nasty shock. So this video will obviously have had a warning at the beginning, just warning that it can be dangerous if not done properly. So stay safe, both in regards of the virus and also if you need to repair your power supply for whatever reason. I do recommend the use of regulated supplies like this, but there's nothing. But most modern switch mode supplies are actually clean enough to actually put out decent voltage and shouldn't cause you any QRM. But make sure it's one that will work with a radio perfectly fine. Just try not to use something like a computer power supply, because that can generate a bit of noise. Although the one I used in there for the Roadcom worked fine. So 7 for now, guys, and stay safe. Definitely stay safe, and I'll catch you in the next video. Bye for now.
Don't forget, you can subscribe to this channel and ring the bell to be notified of new videos as I upload them. 73 is from Paul, Mike 0 Whiskey November Uniform, or 26 Charlie Tango 730 on 11 meters and PMR 446.